Welcome to clickmyproject.com. Let's discuss on the title Noise Reduction and Adaptive Contrast Enhancement for Local Tone Mapping. In this paper, we propose a noise reduction method and an adaptive contrast enhancement for local tone mapping. After initial compression of the luminescence of HDR image, the proposed local TM algorithm decomposes an initial compressed luminescence into multiscale subbands using the discrete wavelet transform. The decomposed subbands are then filtered using bilateral filter and soft thresholding algorithm, and then the local contrast is enhanced by an adaptive weight which is derived from the luminescence compression function with the color constraint. Finally, the color of the tone mapped image is reproduced using an adaptive saturation control parameter. In experiments, the tone map color image of the produced local TM algorithm is compared with the conventional TM algorithms with post-processing. Computer simulation with noisy HDR images shows the effectiveness of the proposed local TM algorithm in terms of visual quality as well as local contrast and detail preservation. Let's have a go through on the data flow diagram. Regarding the data flow diagram, you have to consider three inputs which have multiple exposures. For example, low exposure, mid exposure and high exposure images as an input, and you have to construct an HDR image using these input exposures. And for the HDR image you constructed, you have to do luminescence compression which follows an algorithm that is dependent upon the logarithmic function. And the luminescence compressed image is fed to decomposition using Haar wavelet, and the subbands are being denoised using bilateral filter and subband thresholding algorithm. Using the denoised output and the thresholded output, you have to make a local contrast enhancement in order to improve the quality of the tone mapped image. Finally, you have to concentrate on the color reproduction using the saturation parameter. Now let's have a discussion on the implementation of the program. Regarding the execution, the main file in the program is main_tone mapping. It has been designed in Guy, so you'll be having two files, one is figure file and one M file. You have to click this M file and press run file. This is the design mode window chosen for executing the program. You have to select any one of the input exposures. I am selecting house exposure. So this is a low exposure image, mid exposure image and high exposure image. You have to generate an HDR. You will receive a message box after the HDR image has been generated. Then you have to do luminescence compression, and this is the HDR log luminescence image, and this is the LDR value separated from that. And you have to do an adaptive tone mapping where denoising and the color reproduction, both the operations will be done under this particular button. This may take some time. The execution has been completed. This is the denoised result. You can notice some color saturation and color reproduction is necessary in this denoised output. Finally, when we perform adaptive tone mapping algorithm, we will be getting an output similar like this, where each and every part of the color pixels have been reproduced. And finally, the analysis stage, we will be computing the MSE and contrast sensitive noise ratio for low exposure image, mid exposure image and high exposure image. So this is your final output. And in this paper, a noise reduction method and an adaptive contrast enhancement method for local tone mapping has been proposed. This local tone mapping algorithm consists of initial luminescence compression, image decomposition, noise reduction, local contrast enhancement, image synthesis and color reproduction. For image decomposition and synthesis, we used discrete Haar wavelet transform. The decomposed multi-resolution subbands are filtered using bilateral filter. And here for bilateral filter, we will produce only the LL subband And the soft thresholding, the remaining 3 subbands LH, HL and HS subband will be given for reducing the coarse grain noise. And then the local contrast is enhanced by adaptive weight, which is derived from luminescence compression function with the color constraint. Finally, the color of the tone mapped image is reproduced using an adaptive saturation control parameter. Noise reduction and color reproduction methods can be combined with other TM algorithms for noise and false color suppression. The tone mapped image of the proposed local TM algorithm will give better image quality than those of the conventional TM algorithm. Thank you.